Hello student, the question says in an ammeter, 0.2% of main current passes through the galvanometer. If resistance of galvanometer is G, the resistance of ammeter will be. So let us try to understand the concept in this problem first. If you look at the concept of this problem, first you should know what is a galvanometer. You can think a galvanometer as a device with very medium resistance. So medium resistance could be around 100 to 1000 ohms. You can think galvanometer is a device with a medium resistance. Now, what is an ammeter? Ammeter is a device with very low resistance. Now, how can I create a very low resistance device using a medium resistance device? That means the question is, how can I create a very low resistance using medium resistance? We can actually create a very low resistance from medium resistance by connecting a low resistance device in parallel with the medium resistance. This low resistance device that we connect in parallel to this galvanometer is called a shunt. Why? Because this is a property of parallel resistors. If you connect two resistors in parallel, their effective resistance, their R effective, would be lesser than both the resistances. Like example, let us take the resistance of galvanometer as 100 ohm, the resistance of the shunt as 1 ohm. Resistance of galvanometer is 100 ohm and resistance of the shunt as 1 ohm. Now their R effective, you can see it is lesser than the least value of both of them. Their R effective is 100 by 101, which is lesser than 1 ohm. So remember, this is a very important properties when resistors are in parallel. Their effective resistance would be lesser than all the resistance that are involved in this. So it would be lesser than 1. So this is how, if you take a medium resistance, you connect a low resistance in parallel, then you will get even more lower resistance. So this is a very important chart that will help you to solve the problems of galvanometer and voltmeter and ammeter involved. So you take a medium resistance galvanometer, you connect a low resistance device in parallel to this. This is called shunt. You will get even lower resistance. This even lower resistance is basically our ammeter. You take a medium resistance, that is our galvanometer, and you connect a high resistor in series. When you connect a high resistance in series, this has no name. Only a parallel resistance has a name called shunt. For high resistance, we don't have a name. And we will get even more higher resistance, and that is called as voltmeter. That means, in simple terms, if you go inside an ammeter and see, if you go inside an ammeter and see, ammeter is nothing but a galvanometer and a shunt in parallel. A galvanometer and a shunt in parallel, which give an even more lower resistance. So this is how we can understand things. So inside a galvanometer, we have a inside an ammeter, we have a galvanometer and a shunt. If you look at the question, in the question it says the current I is going in the ammeter, and in that 0.2% is going through the galvanometer, and remaining 99.8% is going through the shunt this way. And let us look at a very important equation that I wrote here. What is that? Let me just explain to you. Now, we can replace this entire device with a single resistance, that is the resistance of ammeter. Now, the question is, what would be common in all three of them? What is common in shunt, what is common in galvanometer, and what is common in ammeter? That is common in all three of them. That is their voltage difference across them. Suppose if I try to find the voltage difference across AB. So voltage difference across AB can be, we can just need to travel from this point to this point. So when I travel from A to B, one of the path could be through the galvanometer. I can write the current through the galvanometer into G as the voltage difference across AB. Another path in which I can travel is I can travel through the galvano shunt and I can reach this point B. So another way to find voltage across AB is current through the shunt into resistance of the shunt. Or we can replace this entire device with an resistance of the ammeter. I can write simply whatever is the current flowing through the resistance I into resistance of the ammeter. This is a very important equation in solving these problems. Whenever we need to solve the problems of ammeter, this equation really helps. Now, using this equation, let us solve the problem. In the problem, he has given the current through the galvanometer is 0.2% of the total current. Total current is I. So I can write 0.2 as 2 by 10. Percentage is a fancy way to write 1 by 100 into I. And we will use our equation VAB equals to IG into G, which is equals to I into A. So if I substitute the values, I can write 2 by 10 into 1 by 100 into I into G equals to I into A. Based on this, we can get resistance of ammeter equals to 1 by 500 into G. So directly using this expression, we can find the resistance of an ammeter. Suppose in the question, he is not asking us the resistance of ammeter, we need resistance of the shunt. Then we will use the same expression, IG into G equals to current through the shunt into shunt. We know 0.2% of the total current I is going through the galvanometer. Then how much current would go through the shunt? 99.8% of the total current would go through the shunt. From this, shunt value is simply 0.2 by 99.8 into G. So we can write 2 by 998 into G. So we'll simply get G by 499. So this is the value of shunt resistance, even though it is not asked. So the correct answer for this problem is A equals to 1 by 500 G. So the answer would be 1 by 500 G. That would be my option C. So again, I will repeat. The most important thing you have to understand is this chart. How can I create an ammeter? From a galvanometer. If you want an ammeter from a galvanometer is a medium resistance. How can I create a lower resistance from medium resistance? By connecting a low resistance in parallel, which will result in even lower resistance. How can I create an voltmeter which is a higher resistance from medium resistance? If we connect in series, we will get even higher resistance. So using that logic and keeping this chart and this formula in mind, we can solve the problems of ammeters easily. Hope you understood how I have solved.